Hello, and welcome to another episode of Cooking with Unity. I'm your host, Maximilian Moreau, and with me is my tech, Philip Wilson.
It's exciting.
It's exciting, as always. So, on our last episode, we had a little Star Fox game, and we could move around, and we can shoot the things.
The pew pew pew.
And we added rings that appear randomly, and arches that appear randomly. They currently don't collide with anything, but you can fly through them and pretend that it's all cool.
Well, I mean, the Star Fox ones never collided. The rings didn't.
Well, they did if you hit them.
Well,
the rings didn't, yeah. But
their rings
yeah, but they still collided. They would acknowledge when you went through them.
Yes.
So
this is true.
the arches didn't acknowledge when you went through them, but you could certainly smash into the side of them.
Yes, you could.
And it actually did check for them in a lot of cases, like for the twin blaster power up and stuff. So today we're gonna probably add collision to those things. Maybe add up a scoring system for that. We're going to play around with a Xbox 360 controller that I've got here hooked into my Mac, which is going to have some interesting little properties, but I want to show you how to do it, and if you're on Windows, you'll probably have to do less, honestly. Let's see, what else? And I'd like to do some camera work, both making it so the camera doesn't just stay static forward when you move around and follows the ship to a certain extent. Also make it so that it banks a little bit when you're turning left and right, to give it more of a feel. And then if we have time, we'll get to something else as well. I'm not going to say it because I don't think we're going to have enough time.
I think that's a good call.
Yeah. So let's start with Let's start looking at the controller a little bit. So, I've got an Xbox 360 controller here, wired. I've got it hooked into my Mac, and I'm using what's known as the Debugging driver. I'll have a link for it in the description, but basically it allows you to use this thing on a Mac, which normally Mac doesn't support directly. Now, the one problem with it is this is what the normal controller map for the Xbox 360 looks like if you're on Windows and if you're using Unity. 0 is A, 1 is B, 2 is X, 3 is Y. All these are pretty logically numbered, and it has different axes for the various controls here. Unfortunately, on the Mac, it's all screwed up. The Debugging driver is a good driver, but for whatever reason, the mappings are very haphazard. So you've got 16, 17, 18, 19, 13, 14. There's like no one. The one thing that I can say that is nice is you're not going to get a whole lot of overlap between the two. I guess there's an overlap on 8 and 9.
Yeah.
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 Well, there's even some overlap. So I don't know what the best practice would be to actually handle both types of controllers in your game. Probably you would have to have two different controller mappings, one for your Mac release and one for your PC release.
You could.
For the online, who knows? I'm hoping that Debugging will eventually fix this layout, but I'm not holding my breath. So right now, if we just hit play, we actually already have control working on the Xbox controller because the stick is axis 1, and the horizontal and vertical axes are automatically mapped properly to that. The button for shooting does not work currently, and there's no button on here that actually is button 0, so I can't shoot at all with this thing. We can fix that very easily by just going into the input manager. So if we go into project settings input, now I'm going to try and make it so both still work so that if you're on Windows you aren't going to be put out. So what we're going to do is we're going to duplicate the Fire 1 here. We're just going to hit Command D, and we have a new Fire 1 here. And I'm going to call this Fire 1 Tat for the other, oh wait, no, we want the name to be the same. Sorry. Descriptive name, we'll call this Mac driver. And that's probably not a good choice either.
Can't you just check systems as well? You can check operating systems, right?
You can, but ironically, the input manager in Unity is not extensible to the extent that you would need to do that. You can't actually change the values at runtime.
Oh, interesting.
Which is actually one of the biggest limitations of the built-in Unity input system. I actually am a pretty big fan of the built-in Unity input system, but without that, there's a lot of reasons to replace it with something else. So I'm going to just set this to button 16. So now button 0 and button 16 should both fire. So if I hit play, yay, we can shoot now with the A button. That's fun. So we've got basic movement and shooting control working on the stick. It actually feels pretty nice too. Has real analog control because we set it up that way. We use get axis instead of get button, and that allows us to basically adjust things however you want. So I have really good fine control if I want to of my ship. So much that I might have to actually tweak the controls a little bit so that it feels better. So now that we have a controller, let's go ahead and add a barrel roll real quick, because it's Star Fox, and you gotta do a barrel roll. So
do a barrel roll.
So let's make a let's go into our input manager, and we're gonna make a couple new inputs. We're gonna create so we can just add size to this. So I can make this 17, and the second jump we're gonna call this bank left. I'm going to duplicate that, and we're going to create, so both of these are based on joystick excellence. So we want third axis as triggers. Alright, so third axis, and the other one is fifth and sixth axis. Wow, that is annoying.
Yes. What about the bumpers just for it?
Yeah, we could do that, but I want it to be analog because we have analog. It's nice. So we have to make slightly different logic then for the two. Oh, that is frustrating. So basically what this means is it says third axis triggers. That means that if you press and hold on L, you'll get -1. If you press and hold on R, you'll get +1. If you press both of them, I don't know what you'll even get. Maybe you can't even press both at the same time?
That seems awkward.
Seems really awkward. How would that just be one axis? Well, I'm not going to be testing this on Windows, so we'll get to see if people complain when they download the project file about how to actually handle this. I'm going to give it a shot, though. We're going to see if we can get this working on the first try on all systems. So, bank left, we're going to set this up as... Alright, I'm going to call it something different. So we're going to do one bank left, one bank right. So I'm going to rename this to bank right. And then I'm also going to make an additional one called bank. And that will be for our Windows style control scheme. And hopefully we can actually just make this work. So the bank left is going to be Tattyboggle style, so that's fifth axis. So joystick axis 3, I think is how it works. Let's see. Where is it? Horizontal is... Oh, no. It's type joystick axis and then axis. Okay, never mind. So I don't do... Oh, I guess it didn't like what I put in there anyway. So we want joystick axis, third axis. That's the one we want, right? No, fifth axis.
Fifth axis.
Fifth axis. And then for bank right, we're going to use... We're not doing any button, and we're doing joystick axis, sixth axis. And then bank, we're getting rid of this, and we're doing joystick axis, third axis, I think. Is that what it is for the Windows one? Yep. So for this game, it'll actually work out if they just cancel each other out because it's a banking style system anyway, so at least we're saved by that. If we need to register them as separate buttons, though, I'm not sure how exactly to go about that. So we have our input set up basically for this. I should also set up a duplicate for each of these, at least for bank left and bank right, just so that we can use a keyboard as well. So I'm going to go ahead and do that. So our bank left here, we're going to model this after the horizontal here. So key or mouse button, and then just negative button, positive button. That's easy enough. And then let's actually... Alright, so... We should also probably change the gravity of the axes here a little bit because these are all set up for buttons. So let's go ahead and do that. Bank left. I'm going to put that on. We'll put that on A and D on the key. Oh wait, we are using A and D for one of the movement types, aren't we?
Are we?
Yeah, we'll just get rid of those. Just gonna get rid of these bonus bindings here in horizontal and vertical, and we're gonna make bank left. Negative button is, or sorry, I guess we'll just put this in bank. So negative button is, oh. Yeah, we'll do it as bank. Sorry, I'm gonna delete these. Command delete and command. So we've got one bank right and two banks left. Command delete. Let's just duplicate bank, since this is a single axis method. And this one we're going to switch it to key or mouse button. We're going to have the negative button be A, the positive button be D, and we're going to set the gravity. So 3.001, 3 snap. 3.001, 3 snap. That should do it. So now we have a. So what I've done here, you'll notice that there's several things that have the same name. If they have the same name, all of those will activate this input. So basically, if you press any of those buttons or use any of those axes, it will apply to that name. And that's how we can kind of overload what buttons do what, and allows us to have some controller overlap in different configurations. So let's go ahead and hit play. Just make sure that it runs still. I don't think it's going to do anything special right now. Yep. Okay. Works. So let's add a new script, C# script called bank. It's going to call it bank. And all we're going to do is in update. So we're going to rotate based on a 0 to 1 input, a -1 to 1 input. So at conceptually at -1 we want the plane to be completely rotated to the left 90 degrees, and on +1 we want it to be rotated completely to the right 90 degrees. And so that's going to be our concept. So let's first see what we need to rotate this thing under. So if I go into our plane here, our little jet, and actually we want these to be all attached to the jet. So we're going to use the ship here. I'm just going to see what axis. So we should be rotating around the Z axis, I believe, because we're pointing into the scene. So if we rotate along the Z, yep, there we go. So if we rotate negative, it goes to the right, and we rotate positive, it goes to the left, naturally. So
that's always helpful.
That is always helpful. Wow, that was kind of fascinating. It righted itself. That's potentially bad. Wait, why did it right itself? Okay, we do want to rotate jet. That's what we want to do. That way it won't right itself when we do this. Perfect. All right. So I didn't break anything, did I?
That's the real question. Breaking things is all a part of making games.
Didn't want to change that. Let's do this one 0 again. Make sure that it still runs. Okay, still looking good. All right. So let's do the single axis method for Windows/keyboard. So this is the one that returns a -1 to 1. So we're going to look at what we're going to be looking at is input.getAxis, and the axis name is going to be bank. And this will return our number. So we need to somehow apply this to a rotation of some kind. So we're going to do transform.rotation So transform.rotation equals. So we want it to be, to rotate left, we want it to be negative. We want the rotation to be positive. We're going to get a negative out of there, so that means we're going to have to apply, at least multiply this by a negative value. We're also only going to want to multiply it by 90 if we're in degrees. I'm not sure if we're going to be working in degrees just yet, but let's just go ahead and conceptually do that. So we're going to take our get axis bank, we're going to multiply it by negative 90. Actually, let's put it on the front so it doesn't look like as odd to read. So negative 90 times input.getAxis bank. So that's the conceptual, this is the number that we want, but we want to actually apply this to our rotation in some way. So let's see, new quaternion, is there a builder that's based on Euler angles? No, there's not. Okay, so we don't want to do that. Ah! What did you do? Don't do that again, computer. I was unhappy. Alright, so we don't want new quaternion. Maybe we can just Euler angles equals new vector 3. So this is the z-axis that we're talking about here. And let's just make the other axes what they already were before. So we're going to just call this transform.rotation.Euler angle, or Euler angles. I should use Euler. It actually is Euler. I sometimes use Euler just because I'm an idiot and also because it seems more phonetic that way. But I probably shouldn't be doing that. His name was Euler, not Euler. Is this going to work the way I want it to? Well, let's try it and find out. So I want to actually use the existing Euler angles for the x and the y. So if we hit pull, if we attach this, oh wait, does not have, does not have a definition for Euler angle. Huh. Why doesn't it have that? Shouldn't it have that? I'm not using Euler angle, I'm using Euler angles. Oh. Check the rest of the line max. Better. Not modify a value type return value of unity engine.transform.rotation. I didn't think we were doing that, but I guess we'll just do that. Transform, sorry, vector 3 new rotation Euler equals transform.rotation.Euler angles. New rotation Euler dot z equals what we did here, and then we just set this equals to new rotation. Let's see if that fixes our bug. Is this read only?
Read only, huh?
Not modify value type return value of unity engine.transform.rotation. Consider storing the value in a temporary variable. Huh.
Are you considering it?
So quaternion new plot equals just do that, and then new quat dot equals new rotation Euler, and then set the rotation equal to new quat. Sometimes you have to massage things a little bit.
A little bit. That is absolutely the truth.
Unassigned local variable, new quat, okay, equals new quaternion. And I do not care, whatever, 0, 0, 0. Yeah, whatever, I'm setting it right there. Actually, let's just do quaternion.identity. That'll be cleaner. That way I don't have to remember if the fourth thing is 1 or not. I think it actually is. Alright, so we're moving, and I hit A, and it didn't do anything because we haven't attached the script to anything. So, exactly as we expected it to be. So I'm going to attach it to the jet, and we're going to hit play. Alright, it did something. It very much did something.
Look at it go.
It's actually exactly what we wanted it to, and exactly what we told it to. I just didn't realize that our jet is not facing the direction I thought it was facing.
Mm-hmm.
So, the jet is underneath the ship. This really should be in the ship's level. But this also does a rotate towards that doesn't seem to care about anything. So I'm not going to go with that. I'm going to put it on... Alright. So, I guess we can just use the X rotation here. So, I'm considering putting this as another sub thing, like making another level above it. The main reason is gimbal lock. We're in a situation right now where we're already rotated 90 degrees, so we could potentially lose a degree of movement if we're going to be moving any of the other stuff. I don't think it's going to matter in this game's case, but I'm just mentioning it now because sometimes this can bite you in the butt. So if it does, just make another empty game object, parent it to it, and then do all of the manipulations on that object, and then keep the other one safe. We're not going to do that now for the sake of time, and because I don't think it's going to matter in the long term on this project at least. So let's go to our bank here, and instead of doing Z, we're going to set the X to this. And did we want positive or negative? Oh, this time it actually rotates nicer, so we're going to actually use 90 times input. So we're going to hit play. And there we go.
Oh, look at it go.
Now, right now, that's interesting. So if I press the opposite buttons... So right now, the tweening is actually done from our control scheme thing. Actually, let's see if it works on... Oh, it did something. Ooh. What did it do? Oh, no. Uh-oh. Now it's stuck like that. If I press anything, it just immediately...
Blah.
Blah. Okay, so why is that happening? I didn't even think we were using... Like, we haven't even set up the bank right, bank left. Third axis. Third axis, what does it do on here?
That is a good question.
Oh, it's left and right on the right stick. Naturally. Not doing what I would expect it to do. Though that's probably because of this. There we go. Now it's doing what I kind of expect it to do. But unfortunately... Oh, that's frustrating.
The frustrations of trying to get a controller to work right.
Cross-platform always makes things interesting, and this is the kind of stuff that you have to deal with. And honestly, like, it's really easy to do cross-platform on Unity, mind you. It's not like the old days. The old days were horrifying. But yeah, that sucks. Why is the rotation all off on this now? Oh, I'm getting drift. Oh, it's over. Oh, it's horrible. Managed to drift the ship all over the place somehow. Oh, I see why. Maybe. If I do a little bit of wax on, we can keep rotating the ship. Okay, that's no good. So we may have to do what I said before, where we're going to put a parent object on here, and then we also need to figure out how to deal with the multiple controller issue. I think what I'm going to have to do is I'm just going to support the controller that I have here for right now. It will be in your interest to actually extend this to your own controller if you're doing controller stuff, so research your buttons, and you're going to have to make some tweaks. I may, at a later time, provide a project file that is set up for the Microsoft mapping of this.
Mm-hmm.
And I'm also going to send another email to Teddyboggle to say, hey, I love your driver, I'm glad that it's free, but could you please make the buttons not suck? So, So we're going to get rid of the supporting both. I'm going to go in here, I'm going to keep the controller bank version, sorry, the controller emulation bank version. No, I'm not. We're gonna use bank right and bank left. So we're gonna delete this. And who cares about that either? Let's duplicate this and duplicate this. Sorry about this, guys. 3, yeah, snap, why not? I think snap we might actually want to turn off, but I'm gonna leave it on there anyway. Whoops. Actually, what are the... Yeah, we want all these on here like that. So this one's going to be key or mouse button. Doesn't matter what we set here. And it's going to be negative button, or positive button is D, and then negative button, or positive button on the other one is A. And this one is not a joystick axis anymore. This is a key or mouse button. Alright, so now we're going to modify our script a little bit. So instead of it being input.get access bank, it's going to be bank left. So let's just see if this works first. I don't think this is going to do what we want it to do just yet, but okay, it definitely did something, so that's good. Interesting. Project settings input. Bank left. It's the 5th axis, which is the right one, right? 5th axis, alright, cool. And let's alright, let's write some debug real quick. So let's just in update here, debug.log input.get access bank left, just so that we know what the raw values are that we're working with. So it's 0, it's -1 when I even push it slightly, and then it goes to, wait, what? Huh? Alright, we're not dealing with controllers today. I'm over it. I'm over it. We are going to make banking work, though, at least on the controller. On the keyboard, I'm just going to go into input. Oh, what the heck? Did you see that?
No,
Did you see that nonsense? It was giving... Okay, here, actually, I'm going to do it again for you, just so you can see, just so that you know I'm not crazy. So it's 0, right? It's 0.
Yeah.
That seems right. I'm not doing anything on it. And then I press it down, and I just go slightly, and it goes to -1.
Oh, lovely.
Which, that's not very analog. And I go further, it goes to 1.
That doesn't make any sense.
And then when I release completely, it goes back to -1.
That doesn't make any sense.
Yeah, that's not useful on any planet. So
No, that's really unfortunate.
So I'm going to have more things to talk to that person about. Next time, maybe I'll use a PS3 controller because I think that actually maps exactly the same on both platforms. So
PS3 controller is
Yeah.
great on a Mac.
yeah, so I think that's what we will do next time. I don't have one with me today, though. So we don't care about the ones that use the joystick. Let's just get rid of those so that they don't destroy our efforts. So I'm using Command D to delete these. One of the nice things is any of these lists, you can actually use duplicate Command D and then Command Delete to delete them, and they will delete properly. So
That's cool.
let's delete this one. And then let's save. And let's go into bank. So, for sake of time, we already had the single axis method working. Let's just do it. Project settings, input. We're just going to call it bank.
Oh, that's so funny.
Negative button is A, positive button is D, and we're done. And then we'll just delete bank right. Save it all, and we're going to go into our bank again. We're going to just switch this back to bank. And then we're going to do what I said before. We're going to create a empty game object. We're going to put it in the exact same location as the ship. Actually, as the jet. That'll be probably more appropriate. No, as the ship. So we're going to copy component. We're going to go into our game object. We're going to paste component values. We're going to call this the we're going to change this jet to jet model. And then we're going to put, I'm just going to call this jet. Put this into the ship. Put the jet model into that. Going to remove the bank script from here, and then we're going to throw the bank script onto here. So let's see how this does. So we're moving around with the keyboard, I press A, and oh yeah, now we're back to where we actually wanted to be before, so we're going to change this to Z as opposed to Y, and now it should actually work properly. Hopefully it won't drift.
Hopefully.
That didn't solve it. I didn't save, did I? No, I saved. Huh. Why am I getting beach ball?
Uh-oh.
Why am I getting beach ball? Okay. Oh, it's working now. That was strange. I guess it hadn't recompiled somehow. We want our negative back in there. Negative. Save. Play. What is my computer doing? Why is it dying? What are you doing to me?
Help computer.
Alright, so we've got our banking thing. We're going to hit play again. Let's see if this actually works. Okay, it looks like it's working well enough. So we have our banking, but we don't have our barrel roll yet. Let's get the barrel roll working. Seems like a lot of work for a barrel roll, but I was thwarted by my controller more than I thought I was going to be. So barrel roll. Let's create a couple variables. Public float barrel double tap frequency. No, frequency is not the word for it. Double tap delay. What do you think would be a good name for a variable that is the amount of time between taps to count as a double tap?
Double tap delay sounds fine.
Okay. So let's make this 0.2f to start. And I think that's all we're going to need. We may need some private variables in here. So if the axis is 0, because we're dealing with these as triggers, so it's a little bit trickier. You can't just actually wait. Do the axi actually? Let's see if we can get an axis as a button. Unity, use axis as button. I'm just curious what axis down. You gotta check it yourself. Okay, that's what I thought. But let's. I just wanted to make sure that I wasn't missing something cool. We could always double up and actually make a button designation for this too, but we're not going to because that might mess up our analogness. So we're going to if. Let's actually get our input.get access right now. So we're going to do float bank access equals input.get access bank. We're going to change this to bank access. This is so that we don't have to keep querying the input system for it. We have it stored locally now. So if bank access oh yeah, it just hasn't added it to the database yet. If bank access is less than 0, public, so private, float time. If bank access is not equal to 0, 0f, then we are going to reset the timer. So time equals 0.0f. And then we're going to else if bank access let's just do else time equals plus equals time dot delta time. Now finally, oh wait, we don't want it to reset the timer necessarily at 0. We want it to reset only if the time has elapsed at 0.
Do you want it to be more of like a countdown?
Alright, let's set it up as a secondary button. Is there a way to do that? Probably can do that in the keyboard setup, but I'm not sure. Yeah, let's not do that. Alright. So, what we want. We need a timer. If you hit the button, axis switches from 0 to non-0. The timer starts. It resets when you go from 0 to non-0 again, and does a barrel roll if you do this within the time limit. Sometimes if you just describe things in plain text, you will find that you'll figure out the problem real quick. So we're going to, if bank access does not equal 0, we're going to create a new private float, a private bool, button up equals true. We're going to default this to true. So button up equals true in this case. If bank access does not equal, oh, it does not equal. So if it equals button up equals true. Maybe I should do this as button down instead of button up. Let's do that, because it's more similar to the nomenclature you're existing. False, button down, false. If button, is it else? If button down equals false. So this else if only happens if the bank access does not equal 0.0f. So under the assumption, so we are not at 0. So that's an implied aspect here that may be harder to catch by the way that I wrote this down. So I just wanted to put that out there. So button down equals false. That means button down equals true. And time equals 0.0f. So if button down equals false, so that'll only happen once, and then it will turn back to false when you go down to 0. So in here we should also check before we set the time to 0.0f. We're going to do if time is less than double tap delay. If time is less than double tap delay, then we're going to do a barrel roll. That won't work though, will it? Because that means if we just flash it down, let's try it anyway. So if time is less than double tap delay, then we're going to do a barrel roll. Let's create a coroutine real quick called void barrel. Actually, my enumerator. Barrel roll. And we're going to say we need a direction that can go. I'll just call it barrel roll left for right now. We'll do 2 versions of it. So this one is just going to be our standard style of coroutine that does a rotation. So I'm going to create a new variable here called public float barrel roll duration. Let's make it 1.0f to start. So the barrel roll is going to float t while t is less than barrel roll duration, we're going to transform dot. Why is it doing this to me? Autocomplete is being very nasty to me today. Sync mono develop project. Sometimes this fixes things. So transform. Thank you. All right. Transform dot rotation. Let's see. Maybe we want to just do rotate around. Actually, I think there's a better one. I think it's in the quaternion thing. Quaternion dot look rotation. Rotate towards. This is the one. This is the good one. So what we're going to do is we're going to actually use the half duration here, divided by 2.0 f. The reason we're going to do that is for roll duration. That was the reason it wasn't auto-completing nicely. So turning out rotate towards. So the reason we have to do this in 2 steps is because we need to basically rotate it 180 degrees and then rotate it the other 180 degrees. We actually probably want to rotate it a little bit more than 180 degrees so it does right, but we'll just do 180 for right now. So from quaternion is our initial orientation, so let's store that. Let's do quaternion original equals transform dot rotation. Actually, I think we just want the local rotation even. Local rotation. So now, so we're going to use original rotation, and then the quaternion goal rotation equals original rotation dot rotate. No. Goal rotation dot rotate. There's not just a rotate on here, is there?
Probably not.
From direction to direction to angle axis to string. Alright, so let's see if there's any fancy things. Quaternion dot from to rotation. This takes the from direction, the to direction. We don't want that. Rotate towards. That's the one that does the step thing. Inverse. What does inverse do? I don't think that is what we wanted to do, but let's find out. Quaternion dot inverse unity. Turns the inverse of rotation. Yeah, I don't trust that. I think that'll be facing an entirely opposite direction than what we want. Rotate towards slurp. Alright, fine. Goal rotation will just dot Euler angles. And we're going to set the Euler angles to dot z plus equals 180. Let's just do that. 0.0f. Oh. Wait, we want this to be... I must have deleted something where I didn't think. Since we've already written this, I'm just going to copy and paste it down here. And then we're going to goal rotation equals original rotation. And then we do dot z here. All right, so goal rotation. And then max degrees delta. Oh, that's not actually what we want, is it? We want from to rotation, don't we? Or maybe we want dot slurp or lerp. Yeah, let's do lerp. So original goal, and then float t, which is t divided by barrel roll rotation divided by 2.0 f. Let's put this into parentheses because I think we need them in this case. So we do that. We finally add t plus equals time dot delta time. And then finally, while, so after it's done with that, we go goal rotation dot Euler angles dot z plus equals 180.0 f. Actually, no, we can just do goal rotation to original rotation at that point. So we'll just do the inverse. So while t is less than barrel roll duration, that's the total one. Actually, I guess we're going to want to do divided by 2 again. And so we're going to reset t here, t equals 0. So while this thing, we do the exact same thing. And then we just change it to original rotation and goal rotation. So let's see if this actually works at all. So what's going to happen is if time is less than double tap delay, we do barrel roll left. And so that we don't fight our logic here, we're going to make it so private bool in barrel roll equals false. So we're going to say in barrel roll equals true, and in barrel roll, it auto completed there but won't auto complete here, I am over it, false. So now we just check if not in barrel roll, then we do all this. And let's see what we got. So we hit play. All compiler errors have to be fixed. Let's go to console. Cannot modify a value type, return value of quaternion Euler angles. Consider storing them, and we had this problem before. Oh, I guess I have to, that's stupid. Equals new quaternion, new vector 3. The x will be this dot x, the y will be this dot y, and the z will be this dot z plus 180. It's a lot of work for a little thing, isn't it?
Mm-hmm.
Use of unassigned local variable t equals 0.0 f. And not all code paths return a value. Oh yes, we actually want to yield on this, so yield return null. And then same thing here, yield return null. Does that work? Okay. Good deal. Let's give this a shot. So I hit play, and I have a feeling it's just going to do nothing because, wait, no, it's attached to a thing already. So jet, delta delay. Oh, might help if I actually said start coroutine and then use the string. Lots of little detail work sometimes when you're doing this stuff. I'm kind of happy all these problems happened is so that something that seems really simple sometimes it's not as simple as it looks. This needs to go in one more. Just clean up the code a little bit here. Let's try this again. Okay, so it is actually kind of doing it. We actually need to make it rotate further somehow. Let's try 181. That's probably still not going to fix the problem because it's going to rotate to the closer thing. Yeah. It's close to what we want. All right, let's try this a little bit differently. Let's do, let's see what else we got here. Transform.rotation equals quaternion dot, lerp, rotate towards, this is the thing, right? All right. This is going to work. We're just going to have to massage it a little bit. So let's make it go to 79. And then we're going to do the same thing except for... So we want it to go to the goal rotation. Okay, so when it reaches... Actually, let's just do... Yeah, let's do 179. Let's give it a 180, whatever. So let's massage it here in between our rotates here. So let's just transform dot rotation dot quaternion, there's more useful stuff in there. Dot front to rotation, look rotation, rotate towards. There's nothing that just lets me rotate this a little bit further, is there? So vectors have rotate, right? Vector 3 dot rotate towards, yeah, it does. And I could probably use some quaternion math comparisons there. Well, let's just be easy about this. So we're going to just create a new one here. Just duplicate this line. And we're going to just add another degree here. 0.0f. So plus 180. So wait, this already has a goal rotation, so we can just do plus 1.0f. Let's see if this fixes our problem anywhere. Oh, it actually went around once there. So obviously we have a few problems, and we still have that dang rotation problem. Wow, this is just not looking so good.
That's unfortunate.
Yeah, seriously. Thought this was going to be easy. I was totally wrong. It's good to be wrong. You can learn from mistakes. Huh. Well, this isn't a very exciting episode if we went from a game that worked totally to a game that has funky rotation. So I'm going to actually keep working on it and see if we can fix it real quick.
All right.
So first, let's make it so that it actually is working right. So if time is less than double tap delay, oh, we're not ever raising our time here. That might be part of the problem. So if time is less than double tap delay, so let's just start time at max int or max float dot max value. So that won't be the case the first time, certainly, and then time plus equals time dot build time. Let's see if this works. So if we hit play, I just press it and it rotates, I press it and it rotates, I double tap it and it does it.
Fantastic.
As far as the direction it decides to rotate, that's seemingly random at this point. I think it's because I'm setting some things wrong. So why is it doing all of this horribleness? Okay, so first of all, let's try not local rotation. Let's just try rotation. I don't think this is going to fix our problem. As a matter of fact, it probably is going to make it worse, but I want to check. So yeah, the ship is still having a lot of troubles. For some reason, it just is rotating. Okay, I'm gonna switch this to non-quaternion stuff. I think we're being too fancy for our own good.
That is possible.
All right, so converting a quaternion to a vector 3 and back unity. Okay, so there's a helper called Euler. Okay, that pattern will probably work pretty well. So, vector 3, initial rotation equals transform dot rotation dot Euler angles. Vector 3 goal rotation equals equals initial rotation, not minus, equals goal rotation dot z plus equals 180.0 f, and then we're going to get rid of this stuff. We basically already did that. So transform.rotation equals quaternion.Euler, and then we give it, wait, okay, what are they doing here? So actually, let's look at this line again. Make sure the semicolon's there because that's what these underlines are complaining about. So let's do vector. Oh wait, vector 3 current rotation equals. I'm just gonna do it here so that it's declared. Equals vector 3 dot 1 or dot 0. We'll just start with there. So current rotation equals math f dot lerp angle. What does this do? Sure, this is basically the same thing. Current rotation. So actually, the current rotation is transform dot rotation dot Euler angles. No, we don't want that at all, do we? Equals math f let's actually do initial rotation here, and then current rotation equals math f dot lerp. We only care about the z actually. Dot z. We lerp from initial rotation dot z, goal rotation dot z, and then t divided by this thing. End our bracket. And then transform dot rotation equals quaternion dot Euler current rotation. So if we just do this again over here, I'm going to get rid of this little doohickey. So now we just swap the initial and goal. We can probably simplify this later, but I'm just looking to make this work first. So goal rotation. All right, let's see if this works a little bit better. So first we're going to have a lot of errors probably. Yep, arrow roll. So how about we do barrel roll? Not arrow roll. God, I messed up that word even worse. All right, that helped a lot. All right, so now we go. Okay, so we can rotate right, double tap it. Oh, lame.
What happened?
I forgot to advance my T. Somehow we deleted that at some point. Plus equals time dot delta time. And so we couldn't rotate. Once you started it, it was over. It locked the position because it's like, I'm in a barrel roll, and then it never gets out.
That's it, huh?
Yep. Better than a hard crash, but it's basically like we crashed just one portion of the game there because it's in an infinite while loop.
Awesome.
So now hopefully it'll work this time. So close. Okay, so now it's always banking left, so that's good. So we're lerping to the goal rotation, and then we're lerping back to the original rotation, which means that it's going to naturally go back like that. So instead, we're just going to I'm going to just put this in here. And then, so we're just adding another 180 there. And we're going to use initial, wait, no, not initial. We're going to use, we want to use the old goal rotation. Alright, let's just redo all of this. Initial rotation equals the current rotation. Goal rotation equals the initial rotation, and the new goal adds 180, and then we set this to be exactly the same. As I said, we can probably clean this up more, but we're not going to worry about it too much. We're just going to try and get something to work. It did a full rotation!
Good deal.
Amazing, and it will do it left both ways. Well, let's just make it so that we can do right. So we're not going to worry about that. We've got a basic barrel roll, and it's late. So anyway, thank you for joining us tonight.
Hang on one second.
Hang on a second.
Yeah.
Do you have something that you want to add to the show?
Yeah, maybe.
Do you have a textured ship?
You know, maybe, but there's a weird texture problem with... we'll just wait for next time.
Okay.
Dang it.
Sorry about that.
It's cool.
Phil's been working his butt off making the ship cooler in the on my right here. So anyway, thank you for joining us tonight. Blah 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 blah. Would you, if you'd like to email us or email me, do pushypixels@pushypixels.com, and you can tweet me at Dragfire. And you should buy Phil's Game Automation.
And if you really want to send me an email, you can. It's philip@protosoftworks.com. You can also follow me on Twitter. That's @magmalemur. And if you want, you should definitely buy Proton Pulse, by the way. What am I talking about? Proton Pulse, buy it. Like, seriously. Seriously, buy it.
Buy Automation, too.
What are you
Seriously,
waiting for?
it's awesome. Both of them are great.
What are you waiting for? You shouldn't be waiting for anything. You should just do it.
Yes.
Do it. Do it.
All right.
Buy
and
it.
you guys have a great week.
Have a good
regardless
week.
of whatever you buy.
Buy our games.
Yeah, you'll have a better week if you buy our games.
That is true.
Somehow, karma will work out. I'm not sure. Maybe the games will make you feel happier.
They will.
We'll find out. Anyway, have a good night.
Good night.